Hello everybody, we're getting ready to do lesson 5.7, Algebra 1, Part 1. Email me here. And for 5.7, Part 1, graph linear inequalities in two variables. Here is your standard. We got 36 points here of classwork skill sheet. And then we got a 10-point notebook guide for this. Teachers, here's your bell work. Write the verbal sentence as an inequality. Then solve the inequality and graph your solution. 4 times absolute deviation of x from 9 is less than 8. And then for number 2, solve the inequality, graph your solution. So 4 times absolute deviation of x from 9 is less than 8. Okay. And I'll give your students about 5 minutes to finish this. Okay, welcome back. And for number 1, our solution would be here. 4 times absolute deviation from x minus 9 would be, I think it's, if I remember right. Anyway, this is the way that we would go from the verbal to the algebra here. And we divide through by 4. We get this, and then x minus 9 is less than 2, and then negative 2 as well. So we have this situation here. And then we solve for x, and then we add 9 to both sides here. And then we get this situation here, and then here will be the graph. It would be a conjoined kind of like plot here, and it would be an imperfect inequality, so the circles will be open. And then down here for number 2, this will be the graph here for number 2. We have this situation here, so we have this equals negative 11 or positive 11. And then we just solve for s by doing our different kind of thing here. And we come up with s is less than negative 3, or s is greater than 13.5. So s will be less than negative 3, but this plot here, and then s will be greater than 13.5 would be this plot. Okay, so before you graph linear equations, two variables, you will graph linear inequalities in two variables. So you get music competition. So linear inequality in two variables, such as x minus 3y less than 6, is the result of placing the equal sign in a linear equation with these inequality signs here. A solution of an inequality in two variables x and y is an ordered pair x, y that produces a true statement when the values of x and y are substituted into the inequality. So students, in your own words, define linear inequality in two variables, and then define a graph of an inequality in two variables. Okay, example 1 here, standard test practice. Which ordered pair is not a solution of this perfect inequality here? Check whether each ordered pair is a solution of the inequality. So we're just going to test. We're going to plug in and see what happens here. 0, 0 substitute 0 for x, 0 for y, 0 is less than or equal to x. Yeah, that checks. 0, 0 could be it. So 0, 0 is a solution of x minus 3y is less than or equal to x. That's one way of doing it. Then we're going to plug in 6, negative 1. So we plug in 6, negative 1 for it. And 9 is less than or equal to 6. No. No. Then 6, negative 1 is not a solution. So the correct answer for being not a solution would be 6, negative 1. Okay, tell whether the ordered pair is a solution of negative x plus 2y is less than 8. So we're going to test 0, 0. Students, this is your problem here. Test this coordinate here, this point. Okay, tell whether it is a solution up here. 0, 0, we plug that into here. Yeah, plug it in, and what do we get? 0 is less than 8. Yeah, solution. Okay, so it's graph of an inequality, graph of an inequality in a coordinate plane, a graph of an inequality in two variables, a set of points that represent all solutions of the inequality. The boundary line of a linear inequality divides the coordinate plane into two half planes. One half plane contains the points that are solutions of the inequality. So, graphing a linear inequality in two variables. Step 1, graph the boundary line. Use dash line for this here, imperfect inequality, and use a solid line for a perfect inequality here with a partial equal sign. Test the point not on the boundary line and by checking whether the ordered pair solution of the inequality. Shade the half plane containing the point if the ordered pair is the solution of the inequality. Shade the other half plane if the ordered pair is the solution. So we're going to graph this linear inequality here. And if you want to, go ahead and graph it here. Y is greater than 4x minus 3. So we already did it here. Here's the graph. Here is 4x minus 3. Here's the line here. Your y-intercept's -3. You have a slope here of 4. So here is your line here. And since it's a partial inequality, the line is dotted. So use a dashed line because of that. So we're going to test 0, 0. To see if the solution is correct, and into that inequality, see if that's correct, and is that correct? Is 0 greater than -3? It does check. So 0, 0 is a solution, and this solution appears to be correct. Okay, graph the inequality. Got to practice here. X plus 3y is greater than or equal to -1. Students, this is yours here. X plus 8y is greater than 16. So let's get to this here. Our guided practice, 3y greater than equal to -6 minus 1. So we're going to move this over here. Divide through by 3, then we get y greater than equal to -1/3 x minus 1/3. That is our solution there. We're going to test 0, see if it's right. 0 test out. That would be our solution for that. Here would be the graph of this. X plus 3y is greater than or equal to -1. We had a slope of -1/3. This is the slope here of the line. And it's 0, 0 will be right here. So this is part of the solution area here for this perfect inequality. And those were the calculator shots. So for part 2, part 3, email me here and you can get that and everything else. Thank you very much.